Hello everyone, this is Mrs. Hunter, and today we are going to talk about gas laws. Alright, so if you are looking at your notes, we're going to go and just start from the top. When we talk about how gases behave and the nature of gases, there are four things that kind of interact and work together and help us describe what's going on. The first is pressure. And if you recall, pressure is caused by all those gas molecules or atoms hitting the sides of their container. So the more collisions you have, the more pressure you have. The second factor is temperature. And if you recall, temperature is a measure of average kinetic energy, which is all about how fast those molecules are moving. The third factor is how much space those gases have to move in, and we call that volume, right? So we know that gases take the shapes of their container, so we are talking about the volume of the container. And finally, how much gas you're working with. So the amount of gas. All right, so before we get into these gas laws specifically, just a couple reminders. Pressure, there's lots of units that we measure pressure in. So you might see pressure in terms of atmospheres or kilopascals or millimeters of mercury or even torr. So you need to be comfortable converting between any and all of these. When we go to plug these into equations, the way you know which to use is that they need to be able to cancel out either with each other or with constants. But we'll get to that when we look at examples. Temperature must always, always, always be in Kelvin. So, more often than not, they're going to give it to you in degrees Celsius. So to get Kelvin, you take your degrees Celsius and add 273. Easy peasy. And volume is pretty easy. It is measured in terms of liters. Now, you can sometimes also see it in milliliters, which hopefully you know 1 liter is equal to 1,000 little milliliters. And finally, the amount of gas. Now, since you're dealing with different substances, we have to talk in terms of an amount that's equal for all substances. And that amount, or that unit, is moles. All right, so the first law we are going to look at is Boyle's law. Now, Boyle was focused on volume and pressure. And what Boyle discovered was that the volume of a gas at a constant temperature is going to vary inversely with the pressure. So, just to clarify, when we say an inverse relationship, right, that kind of means opposite. So, if you were to increase one of these variables, so let's say you increase the volume. So let's say you had gas in a 1 liter container and then you move that gas to a 2 liter container. Well, now you have the same amount of gas moving at the same speed, so same temperature, but you're in a container that's much larger. Well, we're going to see the number of collisions with the side of the wall, aka pressure, will actually go down, which hopefully makes sense. You're in a larger space, you're not going to have as many collisions because there's no other factor changing, therefore pressure ultimately decreases. So things that are inversely related are oppositely related. And his formula shows us two things that are oppositely related. So Boyle's law tells us that initial pressure times initial volume is equal to final pressure times final volume. All right, so there's a few blanks on your worksheet. So wherever you see twos, right, P for pressure, 2 for final, right, so P2 would be final pressure, V2 final volume, P1 initial pressure, V1 initial volume, right? So 1, what you started with, 2, what it ends with. So we are going to, if you were in class, we did the little demos, so catch up with one of your classmates, but let's together take a look at example 1 so we can kind of see what I mean by using this formula. So with these gas law problems, you're going to see a lot of information thrown at you, and what you want to do is either highlight or underline all the bits they've given you, and then we can sort of like a puzzle figure out where everything fits and what it all means. So, example 1, helium gas is compressed from 4 liters to 2.5 liters at a constant temperature. If the pressure in the 4 liter is 210 kilopascals, what will the pressure... Oh, I've cut off my problem. All right, I've cut off my problem. What it should say is, what will the pressure be when the volume decreases? All right. So let's see if we can figure this out. So they've told us that the volume started at 4 liters and ended at 2.5. So our start is V1 and our final volume will go in V2. Now, if the pressure in 4 liters, which remember is our V1, is 210 kilopascals, that means our starting pressure, or our initial pressure, was 210 kPa. So we are looking for our final pressure. All right, now you can totally just plug these into the formula and solve. I prefer to rearrange the formula so that I'm only putting numbers in once. But like I said, I'm totally okay you doing this either way. So, P1 V1 equals P2 V2. And I am trying to get P2 by itself. So, in order to get P2 by itself, to get it alone on that side, we divide by V2. And that will cancel. But if I do it to one side, we all know we have to do it to the other. So, when I've rearranged this formula, in order to get the final pressure, it's going to be initial pressure times initial volume divided by final volume. All right, so I'm going to plug in our variables. So initial pressure, 210 kilopascals, multiplied by the initial volume, which is 4 liters, divided by the final volume, which is 2.5 liters. So when we do the math, let's get our calculators out and do the math. And 210 times 4 divided by 2.5, I got 336. Now let's take a look at those units. If you notice, you have kPa times liters, nothing squares or cancels there, but you're dividing by liters. And so if you have, right, you're dividing by the same thing, it cancels. So you'll notice the unit that we're left in is kPa, which conveniently is the a unit that we can measure pressure in, and we were solving for pressure. So units are another great way to kind of double check that you're doing and setting these up right. Now, we're not quite done yet. We should always round our answer to the correct number of sig figs. So if we take a look, 4.0 liters is 2 sig figs, 2.5 liters, 2 sig figs, 4.0, 2 sig figs, 210, 2 sig figs. So you always round to the least. In this case, they're all 2 sig figs. So 336 will actually round to 340 kilopascals. All right, so this is our short intro, and we will keep looking at all the other gas laws, and I might break this up into 2 videos depending on how much space this is taking on my iPad.